There's a scare in the air. We're going to talk about basic technology of air filtration so you know what the various types can do for you. Let's start out by talking about how particles are captured in a filter. Filters are made up of strands of filter media. Air is pulled through the filter and the air goes between and around the strands of filter media. Particles are pulled along in the air through the filter, and if a particle happens to be larger than the gap between two pieces of filter media, it'll get stuck, just like washing vegetables in a strainer in your sink. So they call this straining. The other way that filters capture particles is when the particle flowing through the air actually hits a piece of filter media and gets stuck. Scientists separate these into three different types, but they all come down to the particle hits the fiber and gets stuck. Let's talk about sizes, because the sizes we're talking about are very, very small, so it's hard to imagine what they look like. Here's an analogy to help visualize the difference between a nanometer and an inch. If 1 nanometer were the size of a green pea, then 1 inch would be the size of Colorado Springs. Just a little more on relative sizes. 1 millimeter is 1,000 microns, or 1,000,000 nanometers. 1 inch is 25.4 millimeters, or 25,400 microns, or 25,400,000 nanometers. Many people think of screens when they're imagining what a filter looks like and how it functions. With a screen, you've got uniform spaces between all of the fibers. Air filters, different from screens, are actually non-woven, and so the spaces between the fibers are not uniform. Filters are rated based upon the percentage of particles larger than 0.3 microns that are captured. Filters used in HVAC systems use what's called the MERV scale. Filters that are designated MERV 1 through 12 are designed to protect the HVAC equipment by keeping detritus and large, very large particles like leaves out of the HVAC system so that the fans and other equipment are not damaged. By increasing the amount of fibers used in creating the filter, you're able to reduce the size of the space between the fibers. That enables the filter to capture more of the particles that are larger than 0.3 microns. A MERV 13 filter will capture up to 75% of particles larger than 0.3 micron. Adding more fibers, creating smaller spaces between fibers, increasing the complexity of the airflow will enable you to create a MERV 14 filter, which will stop between 75 and 84% of those particles. A MERV 15 filter will stop between 85% and 94% of those particles. MERV 16 is also known as a HEPA-fast filter. A HEPA-fast filter can stop more than 95% of particles larger than 0.3 microns. HEPA-fast filters are more commonly found in portable air cleaners rather than in HVAC systems. The next level of filter cleaning efficiency is a HEPA filter. A HEPA filter can clean 99.97% of particles larger than 0.3 microns. For many years, HEPA was the ultimate level of air filtration that was available commercially. Since around the turn of the century, there have been increasing concerns about even smaller pollutants. Microparticles smaller than 0.3 microns, and nanoparticles smaller than 0.1 microns. To capture nanoparticles, filters even finer than HEPA filters are needed. The CHEPA filter is able to capture more than 99.999% of particles larger than 0.003 microns. That's 100 times finer than HEPA filtration. HEPA filtration is good at removing large particles, such as pollen, from the air. For example, ragweed pollen is about 20 microns in diameter. Microparticles smaller than 0.3 microns are difficult for HEPA filters. and nanoparticles smaller than 0.1 microns may pass through HEPA filters. The SARS-CoV-2 virus is estimated between 0.08 and 0.1 microns in diameter. Let's take a moment to understand the size scale of the SARS-CoV-2 virus. For example, if the SARS-CoV-2 virus were actually the size of a ping pong ball, how large do you think that ragweed pollen would be? The ragweed pollen would be the size of a London double-decker bus. That's how big the size difference is. It's relatively easy to create a filter that can stop bus-sized particles. It's much harder to create a filter that will be able to capture and remove the nanoparticles. To understand nanoparticle filtration, it's important to understand how many nanoparticles are in the air. 1 cubic centimeter is about the same volume that you find in a chocolate chip. Each breath you take is about 500 cubic centimeters. HEPA filters are very good with large particles, mid-sized particles, and small particles. There are about 85 of those in every cubic centimeter of moderately dirty air. HEPA filters have difficulty catching all the microparticles, and there are 5 times more of them. There are 445 microparticles per cubic centimeter of moderately dirty air. So there are 222,500 microparticles in every breath you take. Nanoparticles need a special type of filter, and there are nearly 1,000 times more of them. That's about 83,000 nanoparticles in every cubic centimeter, or 41,500,000 nanoparticles in every breath you take. Nanoparticles in the air include airborne viruses. COVID-19 is not the only virus that's in the air. Measles, the common cold, and the flu are all transmitted in the air. The measles virus is 0.12 to 0.25 microns in diameter. SARS-CoV-2 is 0.08 to 0.1 microns. Influenza virus is about the same size. The rhinovirus is 0.03 microns in diameter. That's the common cold virus. Industrial smoke, diesel exhaust, gasoline exhaust, wildfire smoke, cigarette smoke. What do all of these things have in common? Nanoparticles make up more than 90% of those kinds of smoke. Nanoparticles can pass through the lungs and enter the blood. Nanoparticles can then be deposited deep into your organs where they can cause disease. How effective are the various filters in handling nanoparticles? Let's look back at that chart we were looking at before. As you can see, the MERV13 only stops about 75% of the large, mid-size, and small particles. The HEPA filter and the C-HEPA filter eliminate almost all of them. The difference in the types of filters becomes readily apparent when you look at the orange and the red cells. MERV filters and HEPA filters don't even test down to the level of microparticles and nanoparticles. Remember back at the beginning of this video when we were talking about how filters actually stop particles? And some of the particles will actually hit the fibers of the filter. So the number of particles captured by these filters won't be zero. And therefore it might be a reasonable assumption to assume that these filters will drop down a couple of ranks in terms of the amount of particles that they're able to capture. But look how the C-HEPA filter compares, even with this generous assumption, to the other two types of filters. You're looking at less than 415 particles per breath with the C-HEPA filter, compared to 10 million or 33 million particles per breath with the HEPA or the MERV13 filters. And remember, viruses are nanoparticles. C-HEPA is your best protection against viruses and other nanoparticles. C-HEPA filtration, available exclusively from Airgle. Precisely pure. To learn more about how Airgle combines the high-efficiency C-HEPA filter a high-capacity premium activated charcoal filter, and the Titanium Pro hydroxyl radical generating module into a multimodal solution for virus, bacteria, particle, and VOC removal, visit airgle.com.